In this video, we will be learning how to reduce what's called rational expressions. This is based on how we learned how to reduce fractions. So let's go back and look at how do you reduce something like 25 over 30. Now most of you are just going to write down the answer, and that's okay. But let's go back to the basics of how you actually learned how to do that, because it's probably been a while. The reason you can reduce 25 over 30 is because they have a common factor. 25 is 5 times 5, and 30 is 5 times 6. And because they have that common factor of 5 divides into 5 one time, that's how come we can say this reduces to 5/6. Now let's look at 7/9. You should be saying, hey, that doesn't reduce. That's right. So could I do this? That 7 is 6 plus 1 and 9 is 6 plus 3. Can I cancel that out? Well, of course not. No, you cannot do that. 7/9 does not equal to 1/3. That's just wrong. And you're going to go, well, I would never do that. You'd be surprised at what people will do to make things work. So notice you cannot put a plus sign and cancel things out. That's not a common factor. Factors are things that are multiplied together. So let's just look at this next one. Now this is not just a fraction, you could call it that, but it would be a rational expression. A rational expression ratio, meaning that it is a ratio of two expressions. So could I reduce x plus 5 over x squared plus 25? Well, the first question is can I factor anything? You're going, well, I don't think so. All right, so could I do this? Well, let's see. X goes into x squared x time, and 5 goes into 25 5 times. So I have 1 over x plus 5. Is that correct? No. Because of this plus sign, I did not cancel out like factors. Again, factors are things that are multiplied together. Now if I change that problem just a little bit and make that denominator x squared minus 25, could I reduce it? Well, I cannot factor x plus 5. So I'm going to put it in parentheses to let me know that that is a factor. And the only thing that's going to reduce that is another x plus 5. Can I factor x squared minus 25? Well, of course I can. That's the difference of two squares. Now I have things that are multiplied together. I have a common factor of x plus 5. X plus 5 divided by x plus 5 is 1, and so this reduces to 1 over x minus 5. So one more time, you may reduce common factors, but you cannot reduce things that are just added together. It just isn't correct. Looking at this first problem, you'll notice we have lots of things multiplied together. So when I say to factor, it really is already factored for us because everything is multiplied. But I can cancel or reduce some common factors. Well, we know that 2 divides into 8 4 times. And then we have the x's. So we have some properties of exponents. If you have the same base, you can keep the base and subtract the exponents. Remember, there's a 1 there. And since the 3 is bigger on the bottom, I'm leaving the x on the bottom. 3 minus 1 is 2. All right, then I can look at the y's. That's the same base, so I can keep the base, subtract the exponents. And since 5 is the bigger exponent, I'm leaving that on top. Let's see, z's. There's a 1 there. There's more of them up top, so z squared. And don't leave out your negative. You could put it on the top or the bottom. It doesn't matter as long as it's negative. Now the reason why that one's easy is because these were monomials. Now remember, monomials just means it has one term. One term on top, one term on bottom. There's no pluses or minuses. That makes it a lot easier to reduce because they're all factors, they're all multiplied together. So let's look at a more difficult example. Here we cannot just start reducing the x's and the y's because of that sign and that sign. All right, we have subtraction and addition. So that means we must factor. Well, let's review our factoring skills. What do you always look for first when you factor? GCF. So does this top have a greatest common factor? let's see, 2 and 14, they're both divisible by 2. I see an x and a y. Alright, so if I took this top expression and divided them both by 2xy, and I think that's the greatest common factor, what would that leave me? So that would cancel, and that would leave me an x minus 2 goes into 14 7 times. So that would be the factored. I can't factor x minus 7 any further. Now let's find a GCF there. I think there's an x and a y, and again I could take that expression and divide both by xy and reduce that. That would leave me an x plus 3. Alright, so let's look at my factors. I have a 2, an x, a y, and an x minus 7. On bottom, an x, a y, and an x plus 3. Those are my factors. So now can I cancel out any common factors on top and bottom? Do you see anything that's alike? Well, yes, you do. You have the x's and you have the y's. So you would be left with 2, then x minus 7 over x plus 3. And again, I like to put those factors in parentheses just to remind me that that itself is a factor. Now we have some trinomials and binomials. So again, I want to think about factoring. Can't just start canceling because of the subtraction signs. How do I factor that trinomial? Well, the leading coefficient is 1, so that's pretty easy. So I just need to think of two numbers that multiply to get negative 16, but add or subtract to get negative 6. That's negative 8 and a positive 2. And down here, that's the difference of two squares. But the 64 is first, so the 8's have to go first, and the x's have to go last. And again, you need a positive and a negative. So are there any common factors? Well, they're not all exactly alike, but I want you to notice this one and this one. They're not the same, but they are opposites. So what happens when we have opposites? Well, let's just kind of go back to the basics. If I have 2, the opposite of 2 is negative 2. And if I were to reduce that, that would leave me negative 1. If I had negative x, the opposite of negative x is positive x. And if I were to reduce that, I would get negative 1. So if I have x minus 1, the opposite of that one, remember, is 1 minus x. We redid that in a previous video. And the reason why that's the opposite is that you could rewrite this as negative x minus 1. If you distribute that, you would get this. And so if you cancel out, if you reduce those opposites, you get negative 1. So even though x minus 8 and 8 minus x are not the exact same factor, they are opposites, so I can reduce them, but it doesn't leave a 1, it leaves a negative 1. Can you put that on the bottom? Yes, you can. I just like to put that negative 1 on top, just a habit. And so my answer is going to be negative 1 times x plus 2 over, you could write it as 8 plus x or x plus 8. It doesn't matter. But you've got to have that negative, and you have to be able to recognize those opposites. Right, so again, we have a binomial and a trinomial. We need to think about factoring before we start reducing. So this is a good review of cubes. How do you factor cubes? Well, remember, we have a short one and a long one. So what cubed is 8x cubed? 2x. And that would be 3. And remember, we keep the same sign. And then to do the trinomial part, you square that. So that's 4x squared. You square that, always positive. And to get the middle, you multiply together and take the opposite sign. And remember, this trinomial is always prime. Right, so now how we factor this one? Well, my leading coefficient is not 1. But now here is a big hint. idea is that something hopefully will cancel. And so as you're trying some stuff, you might say, well, I have a 2x plus 3 on top, so maybe there's going to be a 2x plus 3 on the bottom, because I know 2 is 2 times 1. And what multiplies to get 9? Well, 3 times 3, or 1 times 9. But since I have that 3 there, I'm going to put a 3 there. So let's see, I just need to get that negative 3x in the middle. That's 3x. That's 6x. If I make that positive and that negative, that's going to get me that negative 3x in the middle. So again, use other parts of the problem to maybe help you factor different parts of the problem. So factor what you know first, and then hopefully you're trying to match something else up, kind of like, oh, well, that matches, put that, just give it a try. All right, so we have factored it. Now I need to cancel out common factors. And yes, the 2x plus 3 divided by 2x plus 3. Remember, when you divide something by itself, it leaves a positive 1. Unless it's an opposite, then it would be a negative 1. And this trinomial here on the cubes, never going to factor. That's a prime trinomial. Over this, and again, I'm just going to put parentheses to be safe. You could have left them out, wouldn't have made a difference. But be safe rather than sorry. Right, so again, you want to factor, and then you want to cancel out any common factors, and you also don't want to forget those opposites.